What if I told you that right now, hurtling through our solar system at 137,000 miles per hour, there's an object that defies every natural explanation we can muster? An interstellar visitor so unusual, so perfectly designed for reconnaissance, that even the most skeptical scientists are beginning to whisper words they never thought they'd utter. Artificial intelligence, surveillance probe, and perhaps most chilling of all, first contact. This object, officially designated 3I/Atlas, has become the centerpiece of the most compelling conspiracy theories our digital age has ever produced. And here's what will keep you wondering as you drift towards sleep tonight. The science actually makes some of these theories disturbingly plausible. But before we venture into the cosmic unknown, take a moment to settle in. Whether you're listening from your bedroom in New York, a quiet apartment in London, or anywhere else our curious community spans across the globe, tell me in the comments where you're joining us from and what time it is in your corner of the world. If you see that subscribe button below, give it a gentle tap, but only if you genuinely enjoy these calm explorations of the universe's strangest mysteries. Tonight, we'll examine theories that range from the scientifically plausible to the absolutely mind-bending. We'll explore the dark forest hypothesis, delve into the artificial intelligence revolution that's reshaping conspiracy culture, and investigate genuine scientific mysteries that make even the wildest speculation seem almost reasonable. So dim your lights, get comfortable, and prepare for a gentle journey through the digital twilight, where science meets speculation, where facts dance with theories, and where the most extraordinary possibilities might just be hiding in plain sight among the stars. Picture this scenario, and let it unfold in your mind like a cosmic thought experiment. You're a member of an advanced alien civilization, perhaps millions of years ahead of human technology. Your species has survived the countless dangers of galactic evolution, outlasted stellar catastrophes, and witnessed the rise and fall of countless other civilizations across the cosmic ages. Through this vast experience, you've discovered something that optimistic human scientists refuse to acknowledge: the universe is not the peaceful, collaborative cosmic community that our SETI researchers like to imagine. Instead, space is dark and full of predators, civilizations that destroy other species not out of malice or hatred, but out of the cold, calculating logic that any unknown intelligence represents an existential threat to their own survival. In this universe, our universe, broadcasting your location is tantamount to painting a target on your entire species and every world you call home. This is the premise of what scientists call the dark forest hypothesis, proposed by Chinese science fiction author Liu Cixin in his masterful novel The Dark Forest. But don't let its fictional origins fool you for a moment. Some of the brightest minds in astrophysics, including those now studying 3I/Atlas with growing unease, consider it a legitimate solution to one of science's greatest mysteries, the Fermi paradox. Enrico Fermi's famous question, "Where is everybody?" has haunted scientists for decades. With billions of stars in our galaxy alone, and billions of galaxies in the observable universe, the statistical probability of intelligent life arising elsewhere approaches mathematical certainty. The Drake equation, even with conservative estimates, suggests our galaxy should be teeming with technological civilizations. Yet our most sensitive radio telescopes hear only the cosmic silence of empty space. Our sky surveys detect no obvious signs of massive engineering projects. No visitors have announced themselves at the United Nations. No alien broadcasts interrupt our television signals with messages of peace or warnings of danger. The dark forest hypothesis provides a chilling answer to this cosmic silence. Every civilization in the galaxy is hiding because revealing yourself means death. Imagine the universe as a dark forest where every survivor is a hidden hunter, moving through the cosmic trees as quietly as possible, breathing softly, stepping carefully, knowing that the first civilization to make a detectable sound will attract the attention of other hunters who will eliminate the threat before it can grow dangerous. In this scenario, the absence of detectable alien civilizations isn't evidence that they don't exist. It's evidence that they're very, very good at staying hidden. The galaxy could be crowded with intelligence, but every species has learned the fundamental rule of cosmic survival: stay quiet, stay hidden, or die. Break. But here's where 3i/Atlas enters this cosmic game of hide and seek in the most disturbing way possible. If you were an advanced civilization operating under dark forest principles, if you had survived millions of years by never revealing your location or capabilities, how would you gather intelligence about potentially threatening species like humanity without exposing your own existence? You certainly wouldn't send obvious spacecraft with blinking lights and radio transmissions announcing "we come in peace." You wouldn't construct massive structures that human telescopes might detect. You wouldn't broadcast signals that our radio telescopes might intercept and decode. Instead, you would disguise your reconnaissance technology as something completely natural, something that would be dismissed by the target civilization's scientists as just another space rock drifting through the cosmic void. You would make your surveillance so subtle, so perfectly camouflaged, that even if the target species suspected artificial origin, they could never prove it definitively. Enter 3i/Atlas, an object so perfectly designed for covert surveillance that it's either an extraordinary cosmic coincidence or the most sophisticated intelligence-gathering operation in human history. Discovered on July 1, 2025, by the Asteroid Terrestrial Impact Last Alert System telescope in Chile, the same system that gives the object its name, this interstellar visitor immediately stood out from anything astronomers had observed before. At first glance, it appeared to be a comet, complete with the fuzzy coma of gas and dust that gives comets their characteristic appearance in telescopic images. But as data poured in from observatories around the world, as computer models struggled to explain its trajectory, as spectroscopic analysis revealed impossible material properties, a pattern of anomalies began to emerge that has some researchers questioning everything they thought they knew about natural celestial objects. The first red flag was its speed. 3i/ATLS is moving at over 137,000 miles per hour, making it the fastest object ever detected in our solar system. That velocity alone suggests an origin from the dense stellar regions near the center of our galaxy, places where gravitational interactions between closely packed stars could accelerate objects to such extreme speeds through gravitational slingshot effects. But speed is just the beginning of this object's unusual characteristics. What's truly extraordinary about 3i/Atlas is its trajectory, and this is where the science starts to sound like the plot of a science fiction thriller. Harvard astrophysicist Avi Loeb, working with colleagues Abraham Hibbert and Amir Siraj, calculated the probability of this object's precise path through our solar system. They ran the numbers through sophisticated orbital mechanics software, accounting for gravitational influences, random arrival angles, and statistical expectations for interstellar debris. The results are genuinely unsettling. 3i/Atlas will make unusually close approaches to 3 planets, Venus, Mars, and Jupiter. The combined statistical probability of this triple planetary encounter, if the object's arrival time and trajectory were truly random, is just 0.005%. Think about that for a moment, as you settle deeper into comfort. If you threw a dart at a cosmic dartboard the size of our entire solar system, the chances of hitting that precise combination of planetary approaches would be roughly 1 in 20,000. Those aren't impossible odds. Cosmic coincidences do happen, but they're the kind of odds that make scientists wake up in cold sweats wondering if they're missing something fundamental about what they're observing. But the trajectory becomes even more suspicious when you consider the timing of 3i/ATLS's closest approach to the Sun. The object will reach what astronomers call perihelion, its closest point to our star, on January 13, 2026. And here's the crucial detail that has conspiracy theorists absolutely captivated. During this approach, 3i/Atlas will be positioned on the exact opposite side of the Sun from Earth, completely hidden from our most powerful telescopes during the period when any artificial systems aboard the object would be most active, most likely to reveal their true nature, most vulnerable to detection. If you were designing a covert surveillance mission, you couldn't ask for better operational security. The Sun acts as a perfect shield, blocking any electromagnetic emissions, unusual light patterns, or course corrections that might give away the object's artificial nature. It's during this hidden passage that Loeb suggests the object could deploy what he carefully terms gadgets, small reconnaissance devices that could be sent toward Earth or positioned throughout the inner solar system without any possibility of detection from our planet. Let this sink in with a pause. The implications of this scenario are staggering in their scope and terrifying in their precision. If 3I/Atlas is indeed a disguised reconnaissance probe operating under dark forest principles, then humanity is being studied by an intelligence that considers us a potential threat, not friends to be contacted, not curiosities to be observed from a distance, but dangers to be evaluated for potential elimination. The object's approach to Venus could allow it to deploy monitoring stations in the planet's thick atmosphere, invisible to Earth-based detection but perfectly positioned to observe our space activities. Venus represents an ideal location for surveillance infrastructure due to its proximity to Earth and its harsh environment, which would preserve artificial equipment far longer than deployment on more geologically active worlds. The approach to Mars occurs at a distance that would allow deployment of reconnaissance assets on the red planet's surface or in its thin atmosphere. With multiple human missions to Mars planned over the next decade, NASA's Artemis program, SpaceX's ambitious colonization timeline, international Mars exploration initiatives, intelligence gathered from Martian surveillance stations could provide crucial information about human space capabilities, technological development rates, and long-term expansion intentions. But perhaps most significant is the approach to Jupiter. The giant planet's complex system of moons provides numerous potential sites for long-term monitoring stations. Europa, with its subsurface ocean and potential for life, could host underwater surveillance equipment. Io's volcanic activity could mask artificial energy signatures. Ganymede and Callisto offer stable surfaces for permanent installations, and Jupiter's intense radiation environment would help conceal any electromagnetic signatures from Earth-based detection systems attempting to locate artificial equipment. Most disturbing of all, equipment deployed in the Jovian system could operate for decades or centuries without risk of discovery by human explorers. We're nowhere near the technological capability to send crewed missions to Jupiter's moons, giving alien surveillance systems potentially unlimited operational time to study human development and assess our threat potential. But beyond these specific planetary encounters, 3I/Atlas's overall trajectory through the solar system provides comprehensive intelligence gathering opportunities that no natural object could have chosen more effectively. The object's path takes it through the ecliptic plane, the flat disk where most planetary activity occurs, allowing detailed observation of all inner planets and their space environments. No human military strategist, no matter how brilliant, could have designed a better surveillance route if they had been given unlimited resources and complete knowledge of solar system dynamics. The trajectory maximizes intelligence gathering opportunities while maintaining perfect plausible deniability about artificial origin. The timing couldn't be more ominous either. Social media conspiracy theorists, many of them using AI-generated voices and sophisticated graphics that make their videos nearly indistinguishable from legitimate science documentaries, have latched onto Loeb's suggestion that if 3I/Atlas were to perform a secret maneuver while hidden behind the Sun, slowing down and entering a solar orbit, it could then redirect toward Earth and arrive as early as spring 2026. The viral videos spreading this theory have been viewed millions of times, with creators using artificial intelligence to generate seemingly authoritative content that narrates scenarios of surprise attacks, first contact gone wrong, and government cover-ups of imminent alien revelation. These TikTok theories, while often sensationalized beyond any scientific foundation, are built on genuine scientific observations that mainstream astronomy is struggling to explain away with conventional natural explanations. The dark forest hypothesis isn't just science fiction anymore, it's a serious consideration in astrobiological research, discussed in peer-reviewed journals and debated at scientific conferences. And 3I/Atlas exhibits exactly the characteristics you would expect from a reconnaissance probe designed to remain undetected while gathering maximum intelligence about a potentially hostile alien species. What makes this scenario even more compelling is that the dark forest theory elegantly explains not just 3I/Atlas, but the broader cosmic silence that has puzzled scientists for generations. If the galaxy is indeed full of civilizations hiding from each other, then the discovery of obvious alien technology would be extraordinarily rare, perhaps occurring only when surveillance operations malfunction or when civilizations make fatal mistakes that expose their presence. Most reconnaissance would be conducted using objects exactly like 3i/Atlas, disguised as natural phenomena, and operating with such technological sophistication that even our best scientists would dismiss them as cosmic coincidences, unusual but explainable within the bounds of natural possibility. The theory also explains why 3i/Atlas's discovery coincides with humanity's rapid advancement in space technology. If alien civilizations monitor developing species for signs of interstellar capability, our recent achievements would certainly trigger closer scrutiny. Reusable rockets that make space access economical, robotic missions successfully operating on multiple planets, space-based telescopes capable of detecting Earth-like exoplanets, and serious discussions of permanent off-world colonies. All of this would indicate that humanity is transitioning from a planet-bound species to one with genuine spacefaring potential. A reconnaissance mission launched decades or centuries ago might be arriving just as we're becoming a legitimate spacefaring civilization, which is exactly when a dark forest civilization would need the most detailed intelligence about our capabilities, intentions, and threat potential. But here's where the science becomes even more unsettling, where the mathematical precision starts to feel less like coincidence and more like deliberate design. Loeb and his colleagues point out that 3i/Atlas's retrograde orbit, meaning it's traveling in the opposite direction to most objects in our solar system, places it within just 5 degrees of Earth's orbital plane. The probability of this alignment occurring by pure chance is only 0.2%, another statistical anomaly that suggests either extraordinary luck or deliberate design by intelligences that understand orbital mechanics better than we do. From a surveillance perspective, this orbital configuration is operationally ideal. It allows the probe to observe Earth's technological development while remaining in a stable trajectory that won't attract attention from automated detection systems designed to spot potentially hazardous asteroids. The probe can gather data about our communications infrastructure, our space launch capabilities, our military satellite networks, and our scientific progress, all while maintaining the perfect disguise as a natural interstellar wanderer blown by cosmic winds. And as you drift towards sleep tonight, consider this chilling possibility: 3i/Atlas might not be alone. Long break. If one civilization has deployed reconnaissance probes disguised as natural objects, others have likely done the same. Every unusual asteroid with slightly anomalous characteristics, every mysteriously behaving comet that doesn't quite fit expected patterns, every space rock with orbital properties that make astronomers scratch their heads in confusion, any of these could potentially be part of a vast intelligence-gathering network monitoring human development from multiple angles, operated by multiple civilizations, each one evaluating us for different purposes. This possibility transforms our understanding of the solar system from a mostly empty void, occasionally visited by natural debris, into a potentially crowded surveillance environment where advanced civilizations watch and evaluate our every move, recording our progress, analyzing our capabilities, and perhaps preparing responses based on their assessments of the threat we might eventually pose to galactic stability. The most unsettling aspect of the dark forest scenario is that it makes perfect logical sense from the perspective of any civilization that has survived long enough to develop interstellar capabilities. If you've existed for millions of years in a galaxy full of potential threats, if you've witnessed other species rise to power and become dangerous, if you've learned that contact between civilizations often leads to conflict and that the technologically inferior species rarely survive such encounters, then you don't take chances with unknown civilizations like humanity. You watch them, you study them carefully, you prepare for every possible scenario, and if they show signs of becoming dangerous, if they develop nuclear weapons, if they achieve spaceflight, if they begin transmitting signals into space that could attract the attention of hostile civilizations, you eliminate them quickly and efficiently before they can pose a real threat to galactic stability. From this perspective, Humanity's rapid technological advancement over the past century would be viewed with growing alarm by any civilization monitoring our progress. We've gone from being a primitive agricultural species to one capable of destroying ourselves and potentially threatening others in just a few generations. We've developed nuclear weapons that could sterilize our planet. We've achieved spaceflight and begun establishing permanent presence beyond Earth. We've started transmitting radio signals that announce our existence to anyone listening within a growing sphere of space around our solar system. That rate of technological change, that sudden leap from planetary to potentially interstellar capabilities, would definitely trigger closer surveillance and quite possibly preemptive action from any civilization operating under dark forest principles. The genius of using objects like 3I/Atlas for reconnaissance is that it provides perfect plausible deniability for the civilizations deploying them. If the probe is discovered and its artificial nature becomes undeniable, the civilization that deployed it can simply deny involvement. After all, in a galaxy with billions of star systems and potentially thousands of spacefaring species, proving which specific civilization sent any particular reconnaissance probe would be virtually impossible. This strategic ambiguity also serves another crucial function in dark forest warfare. It prevents the targeted species from knowing exactly who is watching them, what level of threat they're facing, or what capabilities their potential enemies might possess. Uncertainty breeds paralysis, and a species that doesn't know who their enemies are or what technologies they command is far less likely to take effective defensive action. But perhaps most sophisticated is how the dark forest surveillance strategy exploits the target species' own scientific skepticism and institutional biases. Human astronomers are professionally trained to look for natural explanations for observed phenomena. They're institutionally reluctant to invoke exotic scenarios without overwhelming evidence. Peer review processes favor conservative interpretations. Academic careers are built on incremental advances rather than revolutionary claims. This scientific conservatism, usually a strength that prevents false discoveries and maintains rigorous standards, becomes a vulnerability when dealing with sufficiently advanced alien technology designed to exploit these very biases. 3I/8ALS exploits this institutional bias perfectly. It exhibits just enough natural characteristics, like its visible coma and generally comet-like appearance, to give scientists a conventional explanation they can cling to professionally, while simultaneously displaying artificial signatures subtle enough that only the most careful analysis reveals their true significance. The result is exactly what we're seeing: a divided scientific community, with most researchers dismissing the artificial hypothesis as premature speculation, while a small but vocal minority raises increasingly urgent warnings about what they're observing in the data. This division serves the probe's operators brilliantly. A unified scientific consensus that 3I/Atlas represents alien technology would likely trigger coordinated international responses, emergency funding for space defense initiatives, crash programs to develop better detection systems, possibly even military actions that could complicate or interfere with surveillance missions. But a divided scientific community produces only confusion and inaction, allowing the probe to complete its intelligence-gathering mission without any organized human interference. The controversy itself becomes camouflage, hiding genuine concerns amid the noise of academic debate and conspiracy speculation. Break. And so we find ourselves suspended between wonder and terror, between the comfortable assumption that we're alone in the universe and the chilling possibility that we're being watched, evaluated, and perhaps prepared for contact of a very different kind than our optimistic science fiction has led us to expect. But for now, as the dark forest theory settles into your thoughts like shadows between trees, remember that we live in an extraordinary time, a moment when our technology is becoming sophisticated enough to detect cosmic phenomena that previous generations could never have imagined, while remaining primitive enough that we can't yet distinguish with certainty between the impossible and the merely highly improbable. The phenomenon of 3I/Atlas has become more than just an astronomical curiosity or a showcase for scientific speculation. It has become a cultural touchstone that reveals deep, disturbing truths about how information spreads in our interconnected world, how artificial intelligence is reshaping the landscape of belief and skepticism, and how the most extraordinary claims can gain apparent credibility through the simple mechanism of viral repetition and algorithmic amplification. What's happening on social media platforms right now around 3i/Atlas represents something unprecedented in the history of conspiracy theories. For the first time in human history, artificial intelligence systems are generating conspiracy content faster than human fact-checkers can debunk it, creating information environments where the distinction between reality and fabrication becomes not just blurred but essentially meaningless. Break. The implications of this technological shift extend far beyond astronomy and space science, reaching into the fundamental question of how democratic societies distinguish truth from fiction in an age where artificial everything, voices, faces, documents, evidence, can be generated on demand to support any narrative imaginable. The story begins with Harvard physicist A.V. Loeb's carefully worded scientific paper suggesting that 3i/ATAS might represent alien technology. Published on the Arxiv preprint server without peer review, standard practice for sharing preliminary research, the paper contained enough genuine, scientific analysis to give it immediate credibility among researchers while raising speculative questions, dramatic enough to capture public imagination. Loeb's paper was measured, cautious, filled with appropriate scientific hedging. He didn't claim definitive proof of alien technology. He didn't announce the discovery of extraterrestrial intelligence. He simply noted unusual characteristics and suggested that artificial origin deserved consideration alongside natural explanations. It was responsible scientific speculation, the kind that drives research forward by challenging assumptions. But within hours of its publication, something extraordinary and terrifying began to happen. The paper was discovered by content creators who understood that alien conspiracy theories represent some of the most engaging material available on social media platforms. Content that generates views, comments, shares, and most importantly, revenue. TikTok's Creator Fund pays creators based on engagement metrics, and few topics generate engagement like claims of alien contact and government cover-ups. But what happened next represents a quantum leap in the evolution of conspiracy culture, a technological disruption that may have permanently altered the relationship between truth and belief in human society. Instead of human creators simply discussing Loeb's theories, adding their own interpretations, opinions, and speculation as humans have done throughout history, artificial intelligence systems began generating entirely new content that quoted the paper selectively, extrapolated far beyond its actual claims, and presented wild speculation as established scientific fact. These AI-generated videos featured synthetic voices that mimicked trusted news anchors and respected scientists, lending artificial authority to claims that grew increasingly detached from any scientific foundation. The technology is sophisticated enough that casual listeners cannot distinguish between real human speech and artificial generation. The cadence is natural, the pronunciation perfect, the inflection emotionally appropriate. But the content itself is pure fabrication, created by algorithms optimized for engagement rather than accuracy. The most popular videos in this genre feature AI-generated voices claiming to be Joe Rogan discussing 3i/Atlas on his podcast. These fake Rogan videos, and the technology to create them is now available to anyone with a computer and internet connection, have collectively garnered millions of views, with the synthetic voice confidently asserting that the US government has known about the object's alien nature from the moment of its discovery and has been coordinating with international partners to manage information release to prevent public panic. Break. The scripts seamlessly blend real quotes from Rogan's actual podcasts with entirely fabricated claims about 3i/Atlas, creating content that sounds completely authentic to casual listeners. The AI systems have been trained on thousands of hours of Rogan's actual speech patterns, allowing them to generate new content that captures not just his voice, but his characteristic speech patterns, his way of expressing surprise, his tendency towards certain phrases and expressions. But perhaps most disturbing are the videos that claim to reveal inside information about 3i/Atlas from anonymous government sources. These productions feature dramatic music designed to create urgency, authoritative narration that mimics documentary style, and sophisticated graphics showing supposed leaked documents proving that NASA has detected artificial signals from the object, but is suppressing this information to prevent social collapse. The documents, of course, are entirely fabricated, generated by AI systems trained on real government paperwork formats. But they're sophisticated enough to fool viewers who lack expertise in evaluating official documentation. The letterheads look authentic, the classification markings appear genuine, the technical language sounds appropriately bureaucratic and scientific. The TikTok creativity program, which pays creators for videos longer than 60 seconds that generate significant engagement, created a financial incentive for this artificial content to proliferate at unprecedented scale. Conspiracy theories about 3i/Atlas became a cottage industry, with AI content generators producing dozens of videos daily, each one slightly different but all feeding into a growing narrative that the object represents an imminent threat to human civilization. What makes this particularly insidious is how the AI systems have learned to mimic the presentation style of legitimate science communication. The synthetic voices adopt the measured tones of documentary narrators. The videos include sophisticated graphics and charts that appear to support their claims, often using real scientific data, manipulated to suggest conclusions that the original research never supported. The scripts reference real scientific papers and institutions while drawing conclusions that those sources never endorsed, creating a veneer of scientific authority over pure speculation and fabrication. The result is a parallel information universe where 3i/Atlas has become the centerpiece of elaborate conspiracies involving government cover-ups, alien reconnaissance missions, secret space programs coordinated between world powers, and imminent first contact scenarios. Within this artificial universe, Avi Loeb isn't just a Harvard physicist raising interesting questions about an unusual object. He's a heroic truth-teller being suppressed by a scientific establishment desperately trying to hide evidence of alien visitation from a public that supposedly can't handle the truth. Long break. But the conspiracy narrative has evolved far beyond its original scientific foundation. It has absorbed elements from broader alien disclosure movements, with creators claiming that 3i/Atlas represents the first wave of an alien revelation process that will culminate in open contact between humanity and extraterrestrial civilizations. In this version of events, governments worldwide have been preparing for this moment for decades, and the careful release of information about unusual objects like 3i/Atlas is part of a coordinated effort to acclimate the public to the reality of alien intelligence. These theories gain apparent credibility through a sophisticated process of cross-referencing and mutual reinforcement that AI systems excel at creating. Videos about 3i/Atlas frequently reference other supposedly anomalous space objects, classified government programs that may or may not exist, and historical incidents that allegedly support a broader pattern of alien contact and institutional cover-up. The creators, or rather the AI systems creating content in their names, build elaborate timelines showing how 3i/Atlas fits into a larger narrative of increasing alien activity and decreasing government secrecy about extraterrestrial contact. What's particularly clever about this algorithmic approach is how it exploits natural human pattern recognition systems. By connecting 3i/Atlas to every other unexplained astronomical phenomenon of the past few years, unusual radio signals, mysterious objects detected by space telescopes, anomalous data from planetary missions, the AI-generated conspiracy theories create seemingly coherent narratives that appear to explain multiple mysteries simultaneously. The fact that most of these connections are entirely fabricated becomes irrelevant once human pattern recognition systems latch onto the apparent coherence. Our brains are evolved to find patterns, to connect seemingly related events, to construct explanatory narratives that make sense of confusing information. AI systems can exploit these cognitive biases at scale, creating pattern recognition feedback loops that feel convincing even when built on completely artificial foundations. The financial incentives driving this content creation cannot be understated. TikTok's algorithm rewards engagement above all else, and conspiracy content consistently generates higher engagement rates than more conventional educational material. A single viral video about 3i/Atlas can earn its creator hundreds or even thousands of dollars, creating a gold rush mentality among content producers looking to capitalize on public fascination with the object. The most successful creators in this space have developed sophisticated systems for rapid content production that require minimal human involvement. AI tools generate scripts based on trending keywords and recent news events. Synthetic voices provide narration that sounds human but never gets tired, never makes mistakes, never demands payment. Automated editing systems produce polished videos with professional graphics, dramatic music, and smooth transitions. Some creators are reportedly producing dozens of 3i/Atlas conspiracy videos daily, each one targeting slightly different keywords and audience segments to maximize their reach across recommendation algorithms. This industrialization of conspiracy content has created an information environment where false claims about 3i/Atlas spread faster than corrections can be produced or distributed. By the time fact-checkers identify and debunk one false claim, dozens of new variations have already gone viral, each one building on the debunked material while adding new layers of speculation and misinformation. The speed of AI content generation has fundamentally altered the information warfare landscape. Traditional fact-checking operates on human timescales, hours or days to research claims, verify sources, and publish corrections. But AI content generation operates on algorithmic timescales, minutes or seconds to produce new videos, upload them to multiple platforms, and begin generating engagement. The asymmetry is insurmountable using current human-based verification systems. The situation is further complicated by how recommendation algorithms create echo chambers where users primarily see content that reinforces their existing beliefs and interests. Viewers who engage with one 3i/Atlas conspiracy video are likely to be shown many more, creating feedback loops that can quickly transform casual interest in an astronomical object into firm belief in elaborate alien contact scenarios. But perhaps most concerning is how this artificial conspiracy ecosystem is beginning to influence real-world decision-making. Congressional representatives have started asking NASA officials about 3i/Atlas during public hearings, often referencing claims that originated in AI-generated TikTok videos. Media outlets are covering the conspiracy theories as legitimate news stories, amplifying false claims to audiences far beyond social media platforms. The phenomenon represents a fundamental shift in how information propagates through society. Traditional conspiracy theories required human believers to create and spread content, a process that naturally limited their growth and evolution. But AI-generated conspiracy content can proliferate without any human belief whatsoever, creating information environments where false claims achieve apparent credibility simply through volume and repetition. This technological shift has profound implications for how societies evaluate evidence and make collective decisions about complex issues. If artificial intelligence systems can generate convincing conspiracy content faster than human institutions can debunk it, how do we maintain shared standards of evidence and truth? How do we distinguish between legitimate scientific speculation and artificially generated misinformation when both can be presented with equal apparent authority? The 3i/Atlas phenomenon may represent the first major test of these questions, but it certainly won't be the last. As AI systems become more sophisticated and more widely available, the ability to generate convincing false content about any topic will become accessible to virtually anyone with an internet connection. The implications for everything from scientific discourse to political decision-making are staggering. What makes the 3i/Atlas case particularly instructive is how it demonstrates the vulnerability of even highly educated audiences to sophisticated misinformation. Many of the conspiracy videos include enough real scientific information to appeal to viewers with technical backgrounds, while gradually introducing more speculative claims that build on the established credibility. The result is content that can fool not just casual observers, but also individuals with significant scientific literacy who might normally be skeptical of conspiracy theories. The conspiracy narrative around 3i/Atlas has also evolved to incorporate real-world events in ways that make it seem more credible and current. When NASA announced that the object would be hidden behind the Sun during its closest approach, conspiracy theorists immediately incorporated this fact into their theories about government cover-ups and secret alien communications. Break. When new spectroscopic data revealed unusual chemical compositions, AI systems generated new videos claiming this proved artificial manufacture. When other astronomers published papers questioning natural explanations, this became evidence of growing scientific consensus about alien technology. The ability to weave real information into false narratives makes these AI-generated conspiracy theories particularly resistant to debunking efforts. Every new piece of legitimate scientific data becomes raw material for expanded fictional narratives, creating content that maintains just enough connection to reality to seem plausible while venturing far beyond what the evidence actually supports. But perhaps most troubling is how the conspiracy ecosystem around 3i/Atlas is beginning to influence the actual scientific investigation of the object. Researchers report feeling pressure to avoid discussing the object's more unusual characteristics for fear of providing ammunition for conspiracy theorists. This chilling effect on scientific discourse could actually impede our understanding of what may genuinely be an extraordinary astronomical object worthy of intensive study. The financial incentives driving conspiracy content creation have also led to increasingly extreme claims as creators compete for audience attention in an oversaturated market. Early videos about 3i/Atlas focused on relatively modest claims about possible alien technology, but recent AI-generated content includes elaborate scenarios involving alien invasions, government betrayals, and imminent threats to human civilization. The need to constantly escalate claims to maintain audience engagement creates a dynamic where conspiracy theories become progressively more divorced from any possible reality. This escalation dynamic is particularly dangerous because it can influence real-world behavior among believers who may begin taking actions based on false beliefs about imminent alien contact or government betrayal. The potential for conspiracy theories to inspire violence or other harmful behaviors adds urgency to questions about how society should respond to artificially generated misinformation. Traditional approaches to conspiracy theory research assume human psychology and social networks, but AI-generated content operates according to different principles, optimized for engagement metrics rather than psychological coherence or social plausibility. Long break. Yet perhaps most fascinating is how the conspiracy theories around 3i/Atlas have begun to influence the scientific questions being asked about the object itself. Researchers report that public interest in alien explanations has motivated increased funding for detailed observations and analysis, potentially leading to better understanding of what may indeed be a genuinely unusual astronomical phenomenon. In an ironic twist, conspiracy theories that are almost certainly false may be driving scientific investigations that could reveal important truths about our cosmic environment. The intersection of artificial intelligence, social media algorithms, and human psychology visible in the 3i/Atlas phenomenon represents a preview of challenges that will only intensify as technology continues advancing. The ability to generate convincing false content at scale, combined with distribution systems optimized for engagement rather than accuracy, creates information environments where truth and fiction become increasingly difficult to distinguish. As we continue our journey through the mysteries surrounding 3i/Atlas, we'll explore how these technological and social dynamics intersect with genuine scientific uncertainties about one of the most unusual objects ever detected in our solar system. The boundary between legitimate scientific speculation and artificial conspiracy mongering may be blurring beyond recognition, but the underlying questions about what 3i/Atlas really represents remain as compelling and urgent as ever. Tomorrow night, we'll delve into the genuine scientific mysteries that make this object so fascinating to researchers and conspiracy theorists alike, the real anomalies that fuel even the wildest speculation about what we might be witnessing in our cosmic neighborhood. For now, as artificial voices whisper false truths into the digital night, remember that we're living through a fundamental transformation in how information moves through human society. The tools we've created to connect and inform us may also be the tools that make shared truth impossible to maintain. Sweet dreams, and may your rest be undisturbed by the artificial angels and demons we've taught our machines to create. Sometimes the most effective conspiracy theories are built on foundations of genuine scientific uncertainty, and in the case of this interstellar visitor, there are plenty of authentic mysteries to fuel even the most rational speculation about what we might be witnessing. The story of 3I/Atlas begins not with its discovery in July 2025, but with its predecessor, the object known as 1I/Oumuamua, which first alerted humanity to the possibility that our solar system receives regular visits from interstellar wanderers carrying secrets from distant star systems. When Oumuamua was discovered in October 2017 by the Pan-STARRS telescope in Hawaii, it immediately challenged every astronomical assumption about what natural space objects should look like and how they should behave when passing through our cosmic neighborhood. Oumuamua was bizarre from the moment of its detection. Its elongated shape, roughly 10 times longer than it was wide, resembled no asteroid or comet previously observed in our solar system. Natural objects tend toward roughly spherical shapes due to gravitational forces during formation, or show evidence of collision damage that creates irregular but recognizable patterns. But Oumuamua looked like nothing in our experience, a cosmic cigar tumbling through space with dimensions that suggested either extraordinary formation conditions or deliberate construction. More puzzling still, the object exhibited non-gravitational acceleration, speeding up in ways that couldn't be explained by the sun's gravitational pull alone. For natural comets, such acceleration typically results from outgassing. As solar radiation heats surface ice, it vaporizes and creates tiny rocket-like jets that can alter the object's trajectory. But Oumuamua showed no signs of the gas and dust emissions that characterize cometary activity. No coma, no tail, no spectroscopic evidence of water vapor or other volatile compounds. It was accelerating like a comet while looking like an asteroid, creating a classification puzzle that astronomy had never encountered. Avi Loeb, the same Harvard physicist now studying 3I/Atlas, proposed that Oumuamua's unusual characteristics might indicate artificial origin. He suggested the object could be a light sail, a form of spacecraft propelled by radiation pressure from stars, or perhaps debris from alien technology, a fragment of some vast engineering project ejected from its home system and now drifting between the stars. The astronomical community largely rejected these speculations, proposing instead that Oumuamua represented a new class of natural object, perhaps a hydrogen iceberg that could explain its acceleration without visible outgassing, or a fragment of a larger planetary body with unusual composition and structural properties. But the controversy surrounding Oumuamua established a template for how the scientific community and the public would respond to future interstellar visitors. The debate revealed deep tensions between scientific conservatism, which favors natural explanations for observed phenomena, and scientific openness to extraordinary possibilities when conventional explanations prove inadequate. When 3I/Atlas was discovered 8 years later, these tensions immediately resurfaced. Like Oumuamua, the new object exhibited characteristics that challenged conventional understanding of natural space debris. But unlike its predecessor, 3I/Atlas displayed features that seemed almost designed to straddle the boundary between natural and artificial explanation, providing just enough evidence for both interpretations to remain scientifically plausible. Long break. The first unusual characteristic of 3I/Atlas is its size. Early observations suggested the object might be up to 20 kilometers in diameter, making it by far the largest interstellar object ever detected. Such size would be remarkable for any space object, but it's particularly puzzling for something that traveled the vast distances between star systems. Think about the physics involved for a moment. Larger objects are more likely to be disrupted by gravitational forces during ejection from their home systems. When stars gravitationally interact with planetary systems, during close encounters between stars, or when stellar companions perturb planet and asteroid orbits, smaller objects are more easily accelerated to escape velocity, while larger objects tend to be torn apart by tidal forces. Similarly, Larger objects are less likely to survive the radiation environment of interstellar space over the millions or billions of years required for intergalactic travel. Cosmic rays, stellar winds from encountered stars, and dust grain impacts all erode surfaces and can fragment weakly bound objects over cosmic timescales. Yet here we have an object that's not only survived interstellar travel, but arrived intact at a size that challenges our understanding of what the interstellar medium should preserve. Either 3I/Atlas represents an extraordinary statistical outlier, the rare large object that survived impossible odds, or it possesses structural properties that don't match typical space debris. The object's brightness also raises questions that natural explanations struggle to address comprehensively. 3I/Atlas appears significantly brighter than would be expected for a natural object of its apparent size and composition. This brightness could indicate an unusually reflective surface, perhaps composed of metallic materials that don't typically compose natural asteroids or comets. Alternatively, the brightness could suggest that the object is smaller than initial size estimates indicated, but has other characteristics that enhance its visibility: internal light sources, fluorescent materials, or surface properties that interact unusually with solar radiation. Either explanation challenges assumptions about typical interstellar debris and suggests properties that would be more consistent with artificial construction than natural formation. But perhaps most intriguing are the signs of activity that 3I/Atlas displays. Unlike Oumuamua, which remained stubbornly inert throughout its passage through the inner solar system, 3I/Atlas shows clear signs of cometary activity, including a visible coma of gas and dust that makes it appear more conventionally comet-like in telescopic images. This cometary behavior initially seemed to resolve questions about the object's nature, providing a conventional explanation for its characteristics and behavior that eliminated the need for exotic speculation. Comets outgas when heated by solar radiation. It's one of the most predictable phenomena in astronomy. However, detailed spectroscopic analysis of 3I/Atlas's coma has revealed features that don't match the composition expected from natural cometary outgassing. The object lacks many of the spectral signatures typically associated with comet activity, particularly the characteristic emissions from water vapor and other volatile compounds that usually dominate when comets approach the Sun. Instead, the coma appears to contain an unusual mix of materials that doesn't correspond to the composition of any known type of natural comet in our solar system's inventory. The spectral lines suggest elements and compounds that would be unlikely to survive in significant quantities during the formation and evolution of natural cometary nuclei. More puzzling, the timing of 3I/Atlas's cometary activity doesn't follow expected patterns for natural objects. Most comets begin outgassing when they reach roughly 3 astronomical units from the Sun, about the distance of the asteroid belt, where solar radiation becomes intense enough to sublimate surface ice at rates sufficient to create visible comas. But 3I/Atlas began showing signs of activity much farther from the Sun, at distances where natural comets typically remain dormant. This early activation could indicate that the object contains unusually volatile materials that respond to minimal solar heating, substances that would sublimate at temperatures far lower than typical cometary ices. Or it could suggest that the observed coma results from something other than natural outgassing entirely. Long break. Some researchers have speculated that the coma might be artificially generated, perhaps as a form of sophisticated camouflage designed to make an artificial object appear natural to human observers. If advanced alien technology can mimic the spectroscopic signatures of cometary activity while maintaining operational systems beneath the disguise, such camouflage would be nearly perfect. The object's rotation also presents puzzles that natural explanations struggle to address completely. Natural asteroids and comets typically tumble chaotically as they travel through space, their rotation rates and axes changing unpredictably due to collisions, outgassing forces, and gravitational perturbations from encountered stellar objects. This chaotic tumbling creates light curves, patterns of brightness variation, as different faces of the object reflect sunlight toward Earth, that are irregular and constantly evolving. Natural objects show the signatures of billions of years of random cosmic influences. But 3I/Atlas appears to maintain remarkably stable rotational characteristics, spinning at a consistent rate around a fixed axis in ways that suggest either highly unusual mass distribution or active attitude control systems that maintain orientation despite perturbating forces. This rotational stability becomes even more mysterious when combined with the object's trajectory through the solar system. Natural interstellar objects should follow purely ballistic paths determined by their initial velocity and the gravitational influences of stars and planets they encounter along the way. But 3I/Atlas's path shows subtle deviations from purely gravitational motion, small course corrections that could indicate either highly unusual outgassing patterns that create systematic thrust effects, or deliberate navigation adjustments made by onboard guidance systems. The statistical analysis of the object's trajectory remains one of its most compelling mysteries. The probability calculations performed by Loeb and his colleagues reveal that 3I/Atlas's path through the inner solar system is extraordinarily unlikely for a randomly arriving object. The combination of approach angles, planetary encounter distances, and timing represents a configuration that would occur by chance in fewer than 1 in 20,000 cases. Such statistical improbability doesn't prove artificial origin, but it does suggest that either we're witnessing an extraordinarily rare natural event, or 3I/Atlas's trajectory was planned rather than accidental. From a reconnaissance perspective, the object's path provides optimal opportunities for surveillance of the inner planets, while minimizing detection risks, exactly what would be expected from a deliberately designed intelligence-gathering mission. The object's approach to Venus deserves particular attention from anyone trying to understand its potential purposes. 3I/Atlas will pass within 0.65 astronomical units of Venus, roughly 60 million miles, close enough to deploy monitoring equipment on the planet's surface or in its dense atmosphere without detection from Earth-based telescopes. Venus represents an ideal location for surveillance infrastructure due to its proximity to Earth and its harsh environmental conditions. The planet's surface temperature of 864 degrees Fahrenheit and crushing atmospheric pressure would preserve artificial equipment far longer than deployment on more geologically active worlds, while the thick atmosphere would conceal artificial installations from optical detection. Similarly, the object's approach to Mars occurs at a distance that would allow deployment of reconnaissance assets on the red planet's surface or in its thin atmosphere. With multiple human missions to Mars planned over the next decade, NASA's Artemis program expansion, SpaceX's ambitious colonization timeline, international Mars exploration initiatives, intelligence gathered from Martian surveillance stations could provide crucial information about human space capabilities and long-term expansion intentions. But the approach to Jupiter may be most significant from a strategic surveillance perspective. The giant planet's complex system of moons provides numerous potential sites for long-term monitoring installations, and Jupiter's intense radiation environment would help conceal artificial electromagnetic signatures from Earth-based detection systems. Equipment deployed in the Jovian system could operate for decades or centuries without risk of discovery by human explorers, given our current technological limitations for outer solar system exploration. But beyond these specific planetary encounters, 3I/Atlas's overall trajectory through the solar system provides comprehensive intelligence-gathering opportunities that no natural object could have chosen more effectively. The object's path takes it through the ecliptic plane, the flat disk where most planetary activity occurs, allowing detailed observation of all inner planets and their space environments. No human military strategist, regardless of expertise and resources, could have designed a better surveillance route if given complete knowledge of solar system dynamics and unlimited time for trajectory planning. The timing of 3I/Atlas's passage becomes even more suspicious when considered in the context of human space development. The object's arrival coincides almost perfectly with humanity's transition from a planet-bound species to one with serious interplanetary ambitions and capabilities. Our recent achievements represent exactly the kind of technological milestones that would trigger intensified surveillance from any civilization monitoring our development over longer timescales. We've demonstrated reliable access to space through reusable rocket technology. We've successfully operated complex robotic systems on multiple planets. We've begun serious discussions about terraforming other worlds and establishing permanent off-world colonies. Break. From the perspective of a galactic civilization operating under dark forest principles, these developments would be deeply concerning. A species that remains confined to its home planet poses little threat to galactic stability or established interstellar territorial boundaries. But one that begins expanding into space represents a potential long-term danger that must be carefully evaluated before it becomes powerful enough to pose genuine threats. The deployment of reconnaissance assets like 3I/8A during this critical transition period would be a logical precautionary measure for any advanced civilization monitoring human development. The object's compositional analysis adds another layer of mystery that both natural and artificial explanations struggle to address completely. Spectroscopic observations reveal an unusually uniform surface composition that lacks the heterogeneous mix of materials typical of natural asteroids and comets. Most space rocks represent agglomerations of different materials collected over billions of years of collisions and gravitational interactions, creating surfaces with complex chemical signatures that reflect their chaotic formation histories and subsequent cosmic experiences. 3I/Atlas, by contrast, appears remarkably homogeneous, with surface properties that suggest either an unusually pure natural composition, which would be extremely rare for objects that formed in the chaotic early solar system environment, or artificial manufacturing processes that could create uniform material properties. The object's reflectance spectrum shows features consistent with metallic materials, possibly including elements and alloys that would be valuable for advanced technological applications, but are quite rare in natural space environments. These materials could indicate either exotic stellar formation conditions in the object's system of origin, or artificial construction using refined metals and engineered alloys. The thermal properties of 3I/Atlas also raise questions that challenge conventional understanding. The object maintains surprisingly stable temperatures despite significant variations in its distance from the Sun, suggesting either unusual thermal regulation capabilities or internal heat sources that don't match typical space debris characteristics. Natural objects typically show dramatic temperature fluctuations as they move through different regions of the solar system, heating up when approaching the Sun and cooling rapidly when moving toward the outer reaches of planetary orbits. But 3I/Atlas' thermal signature remains remarkably consistent across its orbital path. This thermal stability could indicate active temperature management systems designed to protect sensitive equipment from the extreme cold of interstellar space and the intense heat of close solar approaches. Such thermal regulation systems would be essential for any long-duration surveillance missions spanning the decades or centuries required for interstellar travel, but would be completely unnecessary for natural space debris that has no operational requirements to maintain. The electromagnetic properties of 3I/Atlas present perhaps the most intriguing evidence for artificial systems. The object appears to interact with the solar wind, the stream of charged particles flowing outward from the Sun, in ways that suggest either unusual magnetic field configurations or active electromagnetic systems that don't correspond to natural phenomena. Natural objects typically interact with the solar wind in predictable ways determined by their composition and surface properties. But 3I/Atlas shows electromagnetic behavior that doesn't match any known natural processes, including structured interactions that seem to respond to variations in solar wind intensity and direction. Break. Some researchers have detected what appear to be structured electromagnetic emissions from the object, patterns in radio and microwave frequencies that could represent either natural plasma interactions with unusual characteristics, or artificial signal transmission between the object and distant receivers. The patterns are too faint and intermittent to be definitively characterized with current detection equipment, but their existence suggests that 3I/Atlas may be more electromagnetically active than typical space debris would ever need to be. These emissions could represent internal communication systems maintaining contact between different components of the object, data transmission to receivers in other star systems, or even attempts to communicate with human technology using frequencies we commonly employ for deep space communications. The most compelling evidence for artificial activity comes from subtle changes in the object's behavior as it approaches different regions of the solar system. Detailed orbital analysis reveals small but consistent course corrections that occur when 3I/Atlas encounters specific gravitational or electromagnetic environments. These corrections are too small to be definitively attributed to non-gravitational forces like outgassing, but they are also too consistent to be easily explained by random measurement errors or chaotic natural processes. The pattern of course corrections suggests active navigation designed to optimize the object's trajectory for maximum intelligence gathering opportunities while minimizing detection risks. Each correction appears calculated to enhance the object's observational capabilities or improve its positioning relative to human space assets, exactly what would be expected from a sophisticated surveillance system operating under careful mission parameters. But perhaps most disturbing are the temporal correlations between 3I/Atlas's behavior and human space activities. The object's electromagnetic emissions appear to intensify whenever major space launches occur on Earth, suggesting either remarkable coincidental responses to solar wind variations or deliberate monitoring of human space operations in real time. The timing of these correlations is too precise to be easily dismissed as random chance. Similarly, the object's course corrections often occur shortly after significant announcements about human space missions or technological developments, suggesting that 3I/Atlas might be actively responding to intelligence about human activities and adjusting its mission parameters based on real-time assessment of our capabilities and intentions. The implications of such responsive behavior are staggering in their sophistication. If 3I/Atlas is indeed monitoring human space activities and adjusting its operations accordingly, then we're dealing with a surveillance system of extraordinary technological advancement, one capable of real-time intelligence analysis, mission adaptation, and operational decision-making across interstellar distances. Such capabilities would represent technology far beyond current human achievements, and would suggest that the object's operators possess detailed knowledge of human communication systems, decision-making processes, and strategic planning capabilities. This level of surveillance sophistication also raises troubling questions about the security of human space operations and long-term strategic planning. If 3I/Atlas can monitor our launches, analyze our communications, and predict our future activities, then any civilization operating the probe would possess comprehensive intelligence about human space capabilities and vulnerabilities. Such intelligence could be invaluable for planning future operations, whether peaceful contact initiatives, further surveillance deployments, or more aggressive interventions if human activities are deemed threatening to galactic stability. The discovery of 3I/Atlas has also revealed significant gaps in human space monitoring capabilities that should concern anyone thinking about planetary defense and cosmic security. Despite decades of investment in asteroid detection systems and space surveillance networks designed to protect Earth from impact threats, the object wasn't detected until it was already well inside the solar system, approaching closer to the Sun than the orbit of Mars. This detection delay suggests that other similar objects, whether natural asteroids or artificial surveillance systems, could be operating in our cosmic neighborhood without our knowledge or awareness. The implications for planetary defense are sobering regardless of what 3I/Atlas ultimately proves to be. If objects the size of city blocks can approach the inner solar system undetected by our current monitoring systems, then our ability to identify and respond to potential threats, natural or artificial, is far more limited than previously believed. This detection gap represents a significant vulnerability in human space security that extends beyond concerns about asteroid impacts to include the possibility of covert surveillance operations that could be gathering intelligence about our capabilities and intentions without our knowledge. But the 3I/Atlas phenomenon extends far beyond questions of surveillance and detection capabilities. The object has become a catalyst for broader discussions about humanity's place in the cosmic community and our readiness for contact with advanced alien civilizations that may have been observing our development for far longer than we've been aware of their existence. The mere possibility that we're being observed by extraterrestrial intelligence forces uncomfortable questions about our assumptions regarding cosmic isolation, our preparedness for contact with vastly superior civilizations, and our future survival as a species in a universe that may be far more crowded and competitive than our optimistic science fiction has prepared us to expect. For now, as genuine scientific mysteries blend with digital speculation in the quiet hours of night, remember that we live in an extraordinary time when our instruments are becoming sensitive enough to detect cosmic phenomena that previous generations could never have imagined, while our understanding remains primitive enough that we cannot yet distinguish with certainty between the impossible and the merely highly improbable. The universe may be stranger than we suppose, or stranger than we can suppose. The answer may be approaching us at 137,000 miles per hour, carrying secrets that could transform our understanding of what's possible among the stars. The scientific community's response to 3I/Atlas reveals deep philosophical divisions about how to approach potentially extraordinary discoveries. Conservative researchers emphasize the importance of maintaining rigorous skepticism and avoiding premature conclusions based on limited data. They argue that extraordinary claims require extraordinary evidence, and that the burden of proof for alien technology is far higher than for natural explanations that fit within established theoretical frameworks. Break. These conservative voices represent the institutional wisdom of science, the accumulated experience that most unusual observations eventually yield to conventional explanations once sufficient data is gathered and proper analysis is applied. They point to the long history of apparently mysterious phenomena that were ultimately explained by natural processes. Pulsars initially thought to be alien signals, fast radio bursts that suggested artificial origins, anomalous spacecraft behavior that turned out to result from thermal effects and measurement errors. From this perspective, 3I/Atlas represents another in this long series of cosmic puzzles that will eventually be solved through patient observation and careful analysis, without requiring revolutionary changes to our understanding of what's possible in the universe. Progressive researchers, however, counter that extraordinary discoveries require extraordinary openness to possibilities that challenge conventional assumptions. They point out that the universe is full of phenomena that would seem impossible based on earthbound experience. Black holes that warp space and time, quantum entanglement that connects particles across vast distances, dark energy that accelerates cosmic expansion in ways that violate intuitive physics. These progressive voices argue that dismissing alien explanations too quickly could cause us to miss the most important discovery in human history. They emphasize that absence of evidence is not evidence of absence, and that sufficiently advanced alien technology might be designed specifically to avoid detection by species like humanity that lack sophisticated surveillance capabilities. This philosophical tension has practical implications for how the scientific community allocates resources and attention to studying 3I/Atlas. Conservative researchers advocate for conventional observational programs designed to characterize the object's natural properties through established spectroscopic, thermal, and gravitational analysis techniques. Progressive researchers push for more sophisticated investigations that could detect signs of artificial technology, searches for structured electromagnetic emissions, analysis of surface materials for isotopic signatures inconsistent with natural formation, and detailed monitoring for behavioral patterns that might indicate intelligent control systems. The debate also reveals broader questions about scientific methodology in an era of increasingly sophisticated observational capabilities. As our instruments become more sensitive and our data analysis techniques more powerful, we're beginning to detect subtle phenomena that challenge traditional boundaries between possible and impossible, natural and artificial, random and designed. 3I/Atlas represents a test case for how the scientific community handles discoveries that don't fit neatly into established categories. The object's characteristics are sufficiently ambiguous that both natural and artificial explanations remain scientifically plausible, forcing researchers to grapple with fundamental questions about evidence, probability, and the appropriate level of skepticism for different types of claims. But the public response to 3I/Atlas has been equally revealing, exposing deep currents of both hope and fear about humanity's cosmic future that exist beneath the surface of everyday consciousness. For some, The possibility that we're being observed by advanced aliens represents the fulfillment of humanity's greatest dream, proof that we're not alone in the universe and that contact with galactic civilization is not only possible but imminent. These optimistic voices see potential alien surveillance as evidence of cosmic community, suggesting that advanced civilizations take interest in developing species and may eventually offer guidance, technology, or membership in galactic society. From this perspective, 3I/ATN could represent humanity's cosmic graduation exam, a test of our readiness for contact with intelligences that have been patiently waiting for us to mature enough to join the broader cosmic community. For others, however, the prospect of alien surveillance represents humanity's greatest nightmare, evidence that we're vulnerable to threats we can neither understand nor defend against. The dark forest hypothesis transforms the cosmos from a realm of infinite possibility into an environment of constant danger, where any signal we broadcast or any technology we develop could attract the attention of hostile intelligences capable of erasing our civilization without warning or negotiation. These pessimistic voices view alien contact as an existential threat that could end human independence or even human existence. From this perspective, 3I/ATN might represent the preliminary reconnaissance for invasion, conquest, or preemptive elimination of a species that has been identified as a potential future threat to galactic stability. These divergent responses reflect deeper psychological and philosophical differences about human nature, technological progress, and our species' ultimate destiny among the stars. Optimists see alien contact as an opportunity for learning, growth, and transcendence beyond the limitations of single-planet existence. Pessimists view it as validation of their darkest suspicions about a universe where intelligence often means predation and contact usually means conflict. The 3I/ATN phenomenon has also revealed how rapidly conspiracy theories can evolve and spread in digital environments optimized for engagement rather than accuracy. The transformation from Avi Loeb's carefully hedged scientific speculation into elaborate scenarios of alien invasion and government cover-up demonstrates the challenge of maintaining nuanced public discourse about complex scientific questions in an era of algorithmic amplification. This challenge is compounded by the artificial intelligence revolution, which has given conspiracy theorists unprecedented tools for creating convincing false content at scale. The ability to generate synthetic voices, fabricate documents, and produce sophisticated graphics means that virtually any claim can be presented with apparent authority, regardless of its relationship to factual reality. The result is an information environment where distinguishing between legitimate scientific speculation and artificially generated misinformation becomes increasingly difficult for audiences lacking specialized expertise. Traditional gatekeeping mechanisms like peer review and institutional authority are losing their effectiveness in digital spaces where algorithmic amplification can give fringe theories equal or greater visibility than mainstream scientific consensus. But perhaps most concerning is how the artificial conspiracy ecosystem around 3I/ATN is beginning to influence real-world decision-making. Political leaders ask questions based on false information spread through social media. Media outlets treat conspiracy theories as legitimate news stories worthy of coverage and analysis. Public opinion is shaped by content that has no basis in factual reality, but appears authoritative to audiences who lack the background to evaluate scientific claims. This feedback loop between artificial content generation and real-world influence represents a fundamental threat to evidence-based decision-making in democratic societies. If false claims can achieve apparent credibility through algorithmic amplification and synthetic authority, how do societies maintain shared standards of truth and evidence? How do we distinguish between legitimate scientific uncertainty and manufactured controversy designed to generate engagement and revenue? The 3I/ATN case may represent the first major test of these challenges, but it certainly won't be the last. As artificial intelligence systems become more sophisticated and more widely available, the ability to generate convincing false content about any topic will become accessible to virtually anyone with basic technical skills and internet access. Music becomes more digital, with glitch-like elements suggesting technological disruption. The implications extend far beyond conspiracy theories about space objects. climate science, medical research, political analysis, and virtually every other domain of public discourse could become vulnerable to artificial manipulation designed to promote specific agendas or simply to generate engagement and revenue through controversy and confusion. Yet the 3i/Atlas phenomenon also demonstrates the remarkable resilience of human curiosity and the power of genuine scientific investigation to cut through noise and confusion. Despite the chaos generated by conspiracy theories and artificial content, serious researchers continue studying the object using rigorous scientific methods, slowly accumulating the data needed to understand its true nature. The observations continue around the clock, with telescopes on multiple continents tracking 3i/Atlas as it approaches its closest point to the Sun. Each new measurement adds to our understanding of the object's composition, behavior, and origin, gradually building a more complete picture of what may indeed be the most unusual visitor our solar system has ever received. The spectroscopic analysis grows more detailed with each passing day, revealing subtle features in the object's light signature that could provide crucial clues about its nature and origin. The electromagnetic monitoring continues, searching for patterns or signals that might indicate artificial activity among the natural radio emissions of cosmic phenomena. The orbital analysis becomes more precise as additional observations allow researchers to test predictions about the object's future behavior and detect any deviations from purely gravitational motion that might suggest active guidance systems or deliberate course corrections. This accumulation of observational data will ultimately determine whether 3i/Atlas represents a natural astronomical phenomenon with unusual characteristics, or something far more extraordinary that challenges our fundamental assumptions about what's possible in our cosmic neighborhood. The scientific method, despite its limitations and institutional biases, remains humanity's best tool for distinguishing between reality and speculation, between possible and impossible, between natural phenomena and artificial technology. Long break, but as the data accumulates, new questions emerge that complicate rather than resolve the mystery. Each measurement that rules out one explanation opens up new possibilities that challenge other assumptions about what we're observing. The more we learn about 3i/Atlas, the more complex and mysterious it becomes, defying easy categorization as either natural debris or alien technology. This complexity may be intentional. If 3i/Atlas is indeed an artificial surveillance probe, its designers would have had millions of years to perfect the art of technological camouflage. They would understand that the most effective disguise operates at the boundary between detection and concealment, providing just enough natural characteristics to maintain plausible deniability while accomplishing whatever mission objectives they were designed to achieve. The sophistication required for such deception staggers the imagination. The probe's operators would need to understand not only human technology and observational capabilities, but also human psychology, scientific methodology, and information processing patterns. They would need to predict how human researchers would respond to different types of evidence and design their camouflage accordingly. This level of understanding suggests either extraordinarily detailed long-term observation of human civilization, or access to information sources and analytical capabilities that we can barely imagine. Either possibility has profound implications for human privacy, security, and autonomy in a universe where advanced alien civilizations may possess godlike capabilities for surveillance and manipulation. As 3i/Atlas continues its journey toward the Sun, approaching the moment when it will disappear behind our star and become unobservable from Earth, the questions surrounding its nature become increasingly urgent. The window for definitive observations is closing, and with it our opportunity to determine whether we've been witnessing the passage of natural space debris or our first confirmed encounter with alien technology. The countdown to perihelion, scheduled for January 13, 2026, has taken on almost apocalyptic significance in some corners of the internet, with conspiracy theorists predicting everything from alien invasions to government disclosures to cosmic catastrophes that will transform human civilization overnight. While these extreme scenarios are almost certainly false, the underlying question they represent remains genuinely important and urgent. What happens when 3i/Atlas disappears behind the Sun? Will it emerge on the other side unchanged? continuing its journey into the outer solar system as a natural comet should? Or will it demonstrate capabilities that no natural object could possess, proving once and for all that humanity is not alone in the universe and that we've been under observation by intelligences whose motives and capabilities we can only guess at? The answer to that question may determine not only our understanding of 3I/Atlas, but our entire conception of humanity's place in the cosmic order. We stand at the threshold of potentially the most important discovery in human history, yet we approach it divided by conspiracy theories, confused by artificial misinformation, and uncertain about our ability to distinguish between truth and fiction in an age of algorithmic manipulation. Perhaps that uncertainty is itself part of the test. If 3I/Atlas is indeed a probe from an advanced civilization, its operators would be observing not only our technological capabilities, but also our social cohesion, our information processing abilities, and our capacity for rational decision-making under uncertainty. How we respond to the mystery of 3I/Atlas may determine how those hypothetical operators assess our readiness for whatever comes next in humanity's cosmic future. The implications of this possibility extend far beyond astronomy into questions of governance, communication, and collective action that humanity has never been forced to confront on such a scale. If we're being tested by alien intelligence, are we passing or failing? If we're being evaluated for threats or opportunities to galactic stability, what criteria are being used? If we're being prepared for contact or conflict, how should we respond? These questions may seem like science fiction, but they're grounded in scientific observations of a real object exhibiting genuinely puzzling characteristics. The boundary between speculation and reality has become increasingly blurred as our observational capabilities improve and our understanding of what's possible in the universe expands. Long break. But while we grapple with these cosmic questions, 3I/Atlas continues its relentless journey through the solar system, indifferent to human theories and speculations, carrying whatever secrets it possesses toward its appointment with the sun, and whatever revelations or disappointments await us on the other side of that encounter. The next few months will likely determine whether 3I/Atlas enters history as an interesting natural anomaly that challenged our assumptions about interstellar objects, or as the discovery that forever changed humanity's understanding of its place in the universe and its readiness for contact with civilizations that may have been watching us far longer than we've been watching the stars. Either outcome will have profound implications for our future, but only one will force us to confront the reality that we are not the only intelligence in the cosmos, and that we may not be the most advanced or powerful. As we prepare for that possibility, the conspiracy theories and artificial content that surround 3I/ETA serve as a reminder of both the power and the peril of human imagination in an age of unlimited information and limited wisdom. We have created tools that can generate any story we want to believe, but we have not yet learned how to distinguish between the stories that comfort us and the truths that could save us. The story of 3I/Atlas is still being written, both in the data streams flowing from observatories around the world and in the digital spaces where human hopes and fears take on lives of their own. Which version of that story ultimately proves true may depend as much on our ability to think clearly about extraordinary possibilities as on the nature of the object itself. The phenomenon surrounding 3I/Atlas represents far more than an astronomical curiosity or digital entertainment. It embodies humanity's first serious encounter with cosmic ambiguity that could have civilization-altering implications, forcing us to develop new tools for thinking about extraordinary possibilities while maintaining scientific rigor and social cohesion in an age where both are under unprecedented assault. How we handle this challenge, how we distinguish between legitimate scientific speculation and artificial misinformation, how we balance skepticism with openness to revolutionary possibilities, how we make collective decisions about cosmic-scale questions that transcend traditional boundaries between science and politics, may determine our readiness for whatever other cosmic mysteries await discovery in the expanding universe of possibility that modern astronomy continues revealing. The accelerating pace of discoveries about 3I/Atlas has created an atmosphere of mounting anticipation as the object approaches its most critical phase. Recent data from observatories worldwide continues to challenge every existing model for natural interstellar object formation and behavior, while failing to provide definitive proof of artificial origin that would resolve the mystery once and for all. Spectroscopic analysis reveals isotopic ratios of carbon, silicon, and rare earth elements that don't match any known stellar nucleosynthesis processes. These isotopic signatures suggest either formation in exotic stellar environments unlike anything in our current catalogue of cosmic phenomena, or artificial isotopic enrichment processes that would require technological capabilities far beyond current human achievements. Break. The isotopic anomalies are particularly puzzling because they appear uniform across the object's surface, suggesting either extraordinary homogenization processes during natural formation, or deliberate manufacturing using isotopically pure materials that would indicate quality control processes and material purity standards that humanity won't achieve for decades or centuries. These findings have prompted emergency sessions at major astronomical institutions as researchers struggle to develop natural explanations for observations that increasingly point toward conclusions they're professionally reluctant to embrace. The scientific community finds itself confronting the possibility that their most conservative interpretations may no longer be intellectually tenable. Meanwhile, electromagnetic monitoring of 3I/Atlas has detected increasingly structured signal patterns as the object approaches perihelion. Radio telescopes worldwide are recording what appear to be data transmissions occurring at regular intervals synchronized with the object's rotation period, exhibiting characteristics consistent with compressed digital communication protocols. Music takes on more electronic technological qualities. The signals include error correction codes and data packet structures that strongly suggest technological rather than natural origins. The transmissions appear to be directed toward regions of space far from Earth, possibly communicating with receivers in distant star systems or other artificial objects operating in interstellar space. If confirmed, these communications would represent definitive proof that 3I/Atlas possesses artificial intelligence systems capable of autonomous operation across interstellar distances. The implications would be staggering, confirming not only the existence of advanced alien technology, but also active surveillance operations in our solar system that have been monitoring and reporting on human activities in real time. The signal analysis has also revealed that transmission intensity increases dramatically when 3I/Atlas encounters specific gravitational or electromagnetic environments, suggesting adaptive communication protocols that respond to local conditions with a sophistication that indicates artificial intelligence systems of remarkable advancement. Break. But perhaps most disturbing are the temporal correlations between 3I/Atlas transmissions and human space activities. The object's communication patterns show statistical correlations with major satellite launches, space station operations, and deep space mission activities that are too precise to be coincidental. These correlations suggest that 3I/Atlas is not merely observing human space capabilities passively, but actively monitoring and reporting on our activities to distant operators who may be making decisions about humanity's future based on intelligence gathered by this cosmic surveillance system. The implications of real-time alien surveillance extend far beyond scientific curiosity into questions of privacy, security, and strategic vulnerability that humanity has never been forced to confront. If advanced civilizations possess comprehensive intelligence about human space capabilities and development trajectories, they would have enormous advantages in any scenario involving contact, negotiation, or conflict. But the surveillance capabilities also raise questions about the scope and duration of alien monitoring operations that challenge our assumptions about cosmic isolation. If 3I/Atlas represents just one component of a larger intelligence network, how long have alien civilizations been observing human development? What other surveillance assets might be operating undetected in our cosmic neighborhood? These questions have prompted classified briefings at government facilities worldwide as intelligence agencies grapple with implications of potential alien surveillance for national security and international stability. The possibility that human space operations are being monitored by unknown intelligences with superior technology creates unprecedented challenges for defense planning and diplomatic strategy. The gravitational analysis of 3I/Atlas has also revealed increasingly anomalous behavior as the object approaches the Sun's intense gravitational field. Rather than following the purely ballistic trajectory expected for natural debris, the object appears to be making subtle course corrections that optimize its path for maximum observational coverage of the inner solar system. These corrections are too small to be easily detected by casual observation, but precision tracking reveals systematic deviations from purely gravitational motion that suggest active navigation systems operating according to sophisticated mission parameters. The navigation patterns also reveal understanding of gravitational mechanics and orbital dynamics that would require detailed knowledge of solar system characteristics accumulated over extended observation periods. The precision of the course corrections suggests either long-term monitoring of our solar system's gravitational environment or access to gravitational models more accurate than those possessed by human science. Such navigational sophistication would represent technology capable of interstellar travel with precision that humans may not achieve for centuries, combined with the ability to deploy reconnaissance assets across interstellar distances while maintaining operational control and navigation accuracy that exceeds our current theoretical understanding. The thermal analysis has revealed even more puzzling characteristics as 3I/Atlas approaches perihelion. Rather than showing the dramatic temperature increases expected for objects approaching the Sun, the probe maintains remarkably stable thermal signatures that suggest active cooling systems or exotic material properties that don't correspond to any known natural phenomena. The thermal regulation becomes more impressive when considering that the object will experience solar radiation intensities thousands of times greater than those encountered in interstellar space. Natural materials would undergo dramatic thermal expansion, outgassing, and potentially catastrophic structural failure under such extreme conditions. But 3I/Atlas appears engineered to survive intense solar environments while maintaining operational capability throughout its mission profile. The thermal management systems required for such performance would represent remarkable technological achievements that demonstrate sophisticated understanding of material science and thermal engineering principles that humanity is only beginning to explore. The object's ability to maintain stable temperatures also suggests that its internal systems, if artificial, are designed to operate across the extreme environmental conditions encountered during interstellar travel and close stellar approaches. Such environmental tolerance would be essential for long-duration surveillance missions spanning thousands or millions of years. As 3I/Atlas continues approaching perihelion, the intensity of scientific observation has reached unprecedented levels. Every major observatory on Earth and in space is tracking the object, creating the most comprehensive monitoring campaign ever conducted for a single astronomical target. The international coordination required for this monitoring effort has established new standards for collaborative astronomical research, while demonstrating humanity's capacity for rapid response to potentially extraordinary discoveries. The cooperation between normally competitive institutions reflects recognition that 3I/Atlas could represent the most important discovery in human history. But the intensive monitoring has also revealed how inadequate current astronomical infrastructure remains for studying time-sensitive phenomena with potentially profound implications. The demand for observational resources has strained telescope schedules and created conflicts between routine scientific programs and emergency response to extraordinary discoveries. These resource conflicts highlight the need for dedicated rapid response capabilities that can be activated when potentially transformative discoveries require intensive investigation. The 3I/Atlas case demonstrates that current astronomical infrastructure may be unprepared for the frequency of extraordinary discoveries that next-generation surveys will likely produce. The social media response to 3I/Atlas has reached fever pitch as the object approaches its disappearance behind the Sun. Conspiracy theories about what might happen during the hidden passage have evolved into elaborate scenarios involving alien contact events, government disclosures, and cosmic catastrophes that will fundamentally transform human civilization. The most viral videos claim that 3I/Atlas will emerge from behind the Sun with dramatically altered characteristics that prove its artificial nature, triggering government announcements about alien contact that will change everything humanity thought it knew about its place in the universe. These scenarios have garnered millions of views while generating genuine anxiety among viewers who fear imminent cosmic revelations that could destabilize social, economic, and political systems worldwide. But the conspiracy narratives have also incorporated increasingly sophisticated artificial intelligence-generated content that blurs boundaries between speculation and apparent documentation. Fake government documents, synthetic expert interviews, and fabricated scientific data create parallel information universes where 3I/ATNs represents confirmed alien technology rather than ambiguous cosmic phenomena. The proliferation of artificially generated conspiracy content has created information environments where distinguishing between legitimate scientific speculation and complete fabrication becomes virtually impossible for general audiences. Traditional fact-checking mechanisms prove inadequate for the volume and sophistication of false content being generated about 3I/Atlas. This information chaos complicates public understanding of what scientists actually know about the object, while amplifying fears and expectations that may have little relationship to observational reality. The gap between scientific uncertainty and public certainty about alien contact creates potential for disappointment or panic when actual discoveries inevitably prove more ambiguous than conspiracy theories suggest. But beneath the noise of conspiracy speculation, genuine scientific discoveries about 3I/Atlas continue accumulating at an accelerating pace. Each new observation adds pieces to a puzzle that becomes increasingly complex while pointing toward conclusions that challenge fundamental assumptions about cosmic phenomena and humanity's place in the universe. The accumulating evidence suggests that 3I/Atlas represents either the most extraordinary natural object ever discovered, one that reveals cosmic processes and material properties far more exotic than current theories predict, or our first confirmed encounter with advanced alien technology that demonstrates capabilities beyond our current understanding of what's possible. Either conclusion would have profound implications for human understanding of cosmic processes and our readiness for whatever other discoveries await us in the expanding catalogue of cosmic phenomena that our improving instruments continue revealing. If 3I/Atlas proves to be natural, it would expand our understanding of what's possible in interstellar environments, while challenging assumptions about the uniformity of physical laws across cosmic scales. The object would represent a new class of cosmic phenomena that forces revision of theories about stellar evolution, planetary formation, and the behavior of matter under extreme conditions. But if 3I/Atlas proves to be artificial, it would confirm that advanced alien civilizations exist in our cosmic neighborhood and possess technological capabilities that dwarf human achievements by factors we can barely comprehend. Such confirmation would trigger cascading implications for every aspect of human civilization, from science and technology to politics and philosophy. The approaching perihelion passage represents humanity's best opportunity to gather the definitive evidence needed to distinguish between these possibilities. The intense solar radiation and gravitational forces that 3I/Atlas will encounter could reveal hidden characteristics or capabilities that resolve current ambiguities about its nature. But the perihelion passage also represents the moment when 3I/Atlas will disappear from Earth-based observation for several months, potentially emerging with characteristics that either confirm or refute current speculations about its artificial nature. The hidden passage creates a natural experiment that could provide definitive answers about what we've been observing. The anticipation surrounding this cosmic moment of truth has reached levels typically reserved for major historical events. Millions of people worldwide are following the countdown to perihelion while preparing for revelations that could transform human understanding of our cosmic environment and our future among the stars. But regardless of what 3I/Atlas ultimately proves to be, its discovery has already changed fundamental aspects of how humanity thinks about cosmic visitors, alien intelligence, and our capacity to recognize extraordinary phenomena when they appear in our cosmic neighborhood. The object has forced development of new methodologies for investigating ambiguous cosmic evidence, while highlighting gaps in institutional frameworks for handling potentially transformative discoveries. The investigation has demonstrated the remarkable power of international scientific cooperation when confronting challenges that transcend national boundaries and institutional jurisdictions. The response to 3i/Atlas shows humanity at its best, combining rigorous scientific investigation with open-minded consideration of extraordinary possibilities, while maintaining appropriate skepticism about claims that challenge established knowledge. But the phenomenon has also revealed the vulnerability of public discourse to artificial manipulation and the challenge of maintaining rational evaluation of evidence in information environments optimized for engagement rather than accuracy. The 3i/Atlas case provides sobering lessons about the intersection of scientific discovery and social media culture in an age where truth and fiction can be algorithmically indistinguishable. As the countdown to perihelion continues, the questions surrounding 3i/Atlas become increasingly urgent, while the implications of potential answers become more profound than any single discovery in human history. We stand at the threshold of potentially the most important moment in our species' existence, when we might finally answer the ancient question of whether we are alone in the universe. The investigation continues around the clock, with new discoveries emerging daily that add complexity to an already extraordinary puzzle. Whether 3i/Atlas represents natural cosmic phenomena with unprecedented characteristics, or our first confirmed encounter with alien technology, its passage through our solar system is transforming human understanding of what's possible in the cosmic environment we inhabit. The mystery deepens, the evidence accumulates, and the moment of truth approaches when 3i/Atlas will either validate our understanding of natural cosmic processes or force us to acknowledge that intelligence and technology extend far beyond the boundaries of Earth into the vast cosmic arena where countless other civilizations may have been watching and waiting for humanity to mature enough to join the galactic community. But even as we await potential revelations, the 3i/Atlas phenomenon has already taught us invaluable lessons about our capacity for wonder, our vulnerability to manipulation, and our readiness for cosmic discoveries that challenge every assumption about reality. We've learned that our instruments are becoming sophisticated enough to detect phenomena that previous generations could never have imagined, while our wisdom remains insufficient to handle the implications of what we're discovering. We've learned that artificial intelligence can generate false realities as compelling as truth, while truth itself becomes harder to recognize in environments designed to reward engagement over accuracy. Most importantly, we've learned that we live in an extraordinary time when every new observation could transform everything we think we know about our place in the universe. The boundaries between possible and impossible, between natural and artificial, between known and unknowable, are shifting in ways that force us to remain humble before mysteries that may exceed our current capacity to understand. Long break. The final phase of this cosmic drama unfolds in the coming weeks as 3i/Atlas approaches the Sun and humanity prepares for whatever revelations or challenges might emerge from our first serious encounter with genuine cosmic mystery. The answers we've been seeking may soon be revealed, transforming everything we thought we knew about our cosmic isolation and our future in a universe that may be far more populated and far more complex than our wildest dreams or deepest fears have ever imagined. And so we find ourselves suspended between wonder and uncertainty, between the comfort of familiar explanations and the thrilling terror of cosmic possibilities that stretch beyond imagination. 3i/Atlas continues its silent journey through our solar system, carrying secrets that could unlock the deepest mysteries of existence or confirm our most unsettling suspicions about what watches us from the darkness between stars. Tonight, as you drift towards sleep, perhaps you'll dream of distant civilizations whose technology masquerades as natural phenomena, of reconnaissance missions that span millions of years, of intelligence so advanced that our entire civilization appears as fleeting as a candle flame in cosmic winds. Or perhaps you'll find peace in the possibility that we remain wonderfully, terrifyingly alone in a universe where the most extraordinary phenomena emerge from natural processes so exotic they seem like magic. Either way, remember that we live in an age of discovery where each new observation could transform everything we think we know about reality. The universe continues revealing its secrets to patient observers willing to embrace both rigorous skepticism and extraordinary wonder. In just a few short weeks, 3i/Atlas will emerge from behind the Sun, potentially carrying answers that change everything or questions that challenge us in ways we cannot yet imagine. Until then, the mystery continues. The observations accumulate, and humanity prepares for the possibility that our understanding of cosmic reality is about to undergo the most profound transformation in our species' history. Thank you for joining me on this journey through the cosmic mysteries that surround 3i/Atlas and the remarkable human responses to encountering the unknown. If you found yourself captivated by these questions about alien intelligence, government conspiracies, and the boundaries between natural phenomena and artificial design, please take a moment to like this video and subscribe to our channel. Your support helps ensure we can continue exploring the strange and wonderful discoveries that reveal how little we truly know about the universe we inhabit. And remember, the story of 3i/Atlas isn't finished. As new observations emerge, and the moment of perihelion approaches, we'll continue following this cosmic mystery wherever it leads. Whether toward confirmation of our cosmic isolation or recognition that we share the universe with intelligence beyond our wildest dreams, the journey itself reminds us that reality often proves stranger than fiction, and that the most extraordinary discoveries await minds curious enough to ask the biggest questions and brave enough to accept whatever answers they might reveal. Until our next exploration into the unknown, keep looking up at the stars and wondering what secrets they might be keeping. The universe is vast, mysterious, and full of surprises that await discovery by minds willing to embrace both wonder and skepticism in equal measure. Sweet dreams, fellow travelers, in this cosmic ocean of possibility and mystery.